All right, welcome back to the channel. Today we're starting our calculus series, and we're just gonna go over the basic proof of the inverse trigonometric functions, the derivatives of the inverse trigonometric functions. And this way, it's an easy way to quickly remember. Instead of memorizing these functions, which they're kind of tricky to memorize, you can just jot down the proof really quick during a test or something if you forget, and that's usually what I do. So let's start out with arctangent. We're gonna find the derivative of arctangent. So this is our problem. The derivative of arctangent of x. So what you do first is you're gonna say let y equal arctangent x. And what we're going to be doing is implicit differentiation to figure out the derivative. So what you're going to do next is just take the tangent of both sides. So it's going to be tangent y equals x, because when you tangent an arctangent, they cancel out. And now we're just going to take the derivative of tangent y. So derivative of tangent is secant squared. So we're going to have secant squared y, and we need to put a dy dx, because it's implicit differentiation. And then for the x, it's gonna go to 1. And then for the next step, we'll just divide over because we're trying to find the derivative. So dy dx is equal to 1 over secant squared y. Now, to get this into the more normal form, what we wanna do is we're gonna use the substitution, or sub back y in here. But first, let's use the simple Pythagorean identity to get this in a simpler form. So we know that sine squared y plus cosine squared y is equal to 1. And then we just divide by cosine squared, and we get tangent squared y plus cosine squared over cosine squared is 1 is equal to secant squared y. So we're going to sub this part right here. It's going to go in here. So we're going to get dy dx is equal to 1 over tangent squared y plus 1. And now for the final step, we have y in the beginning, and we're just going to sub that in for y down here. So it's going to be dy dx is equal to 1 over the tangent of the arctangent x squared plus 1. And this is going to simplify to x squared, so it's basically going to be 1 over x squared plus 1. So there we go. We have our first derivative of the arctangent. All right, so next we're going to take let's do arcsin. It's essentially the same process. So you don't really have to memorize anything new. So we're taking the derivative of arcsin, so it's the same thing. Let y equal arcsin x. Sorry about that. X, and then sine of both sides. Sine y equals x. Now we're going to differentiate sine implicitly, so we're going to get cosine, and then dy dx. Don't forget that part, that's important. And then derivative of x is 1. Bring the cosine to the right side. Now we're going to use our Pythagorean identity again. Sine squared plus cosine squared equals 1. And we're trying to find cosine y. So let's rearrange. Cosine squared y equals 1 minus sine squared y. And we want cosine squared, so let's take the root, square root. We get plus on y equals the square root of 1 minus sine squared of y. Now we're going to sub this in, take this part, sub it in here, and we get it is equal to square root of 1 minus sine squared of y. Now, remember we have y up here, and we're going to sub that in for this y down here. And then we'll have our final answer. Oh, shoot. Sorry about that. 1 minus sine arcsin x. Because we want to get rid of the y because we're looking for the x variable. And that's all squared. So then we have our final answer. Just simply 1 over the square root 1 minus x squared. So that's going to be arcsin x. And yeah, so let's do the last final one, arccosine x. And then that'll be it. So this is just the basic trig ones. Arccosine x. And this is just going to be really similar to sine because their derivatives are pretty similar. So y equals, yeah, we gotta let y equal to arccosine x. Right, and then we just take cosine y is equal to, it's the same process as you see for all of them, so it's easy to remember. And you can do it quickly if you forget the derivative. But if you just want to memorize the derivatives, that's fine as well. So y equals, wait, no. Now we want to differentiate both sides. We're going to get negative sine y dy dx is equal to 1. Take dx, we get negative 1 over sine y. We do the same Pythagorean identity once again. Is equal to 1. Now we're looking for sine instead of cosine. We get sine squared y is equal to 1 minus cosine squared y, square root both sides. 1 minus cosine squared y. Now we sub this in for this one. And we get it's equal to, let's see, 1 over the square root of 1 minus cosine squared y. Now we do the final step, sub in y for this y right here to get rid of the y's. Negative 1 over the square root 1 minus cosine, plug in y, arccosine x, square that. The cosine and the arccosine cancel, so we get our final derivative. Negative 1 over 1 minus x squared. So there you have it. Those are 3 basic, the most common inverse trigonometric functions that you're going to come across in basic calculus like Calc 1. And that's just a quick way of proving them. And if you forget like the memorization of this basic derivatives, this is just a quick way to run through and make sure that you have the right form, because if you don't have the right form, you're probably going to get that question wrong. So that's just a quick way. If you're not good at memorizing, that's how I do it. And thanks for watching.